Today we're going to talk about our third strategy for comparing fractions, which is making the models equivalent. In third grade, anytime you see a fraction, you're going to see a model with it. Okay, so we're going to be trying to make it models, and the word equivalent means equal. So can we make the models have the same number of pieces? So first, we've gone through the first strategy. Do they have like numerators? No. Do they have like denominators? No. So what do we do? Okay, this is where we're going to make the models equivalent if we can. Okay, so with making models equivalent, you're looking for, and we're going to write this in our notes, this will be the first thing, is look for a multiplicative relationship between the denominators. If you need to pause to get that written down, please pause and then restart. Okay, so looking for a multiplicative relationship between the denominators. So what does that mean? Well, multiplicative means what we think it might mean. Multiply. Okay, so looking for a multiplication relationship between the denominators. So for example, 1/2 and 3/6. Could I multiply 2 times anything to get 6? Well, yeah, 2 times 3 is 6. So that's a multiplicative relationship. I could do times 3 to get 6. So that's a relationship based on multiplication between the two denominators. Okay, and that's what we're going to be looking for. It's not as hard as it sounds, so don't freak out. We're going to go ahead and work along with me in your journal. The first example that you should see is 1/2 and 2/4. Okay, so anytime you see fractions, the first thing you're going to do is write down the fraction that's shaded. Now on mine, I have the fraction shaded. On yours, I specifically did not write down the fraction for you because I want you to practice writing down the fraction when you see a fraction. Okay, so I've checked the numerators aren't the same. Check the denominators are not the same. So now I'm checking to see, is there a multiplication relationship between 2 and 4? Could I do 2 times something gives me 4? Yeah, I could do times 2 to get 4. So what that means is that I can make this 1/2. I can split each half into 2 equal pieces, and that will give me 4 pieces. So watch this. I split the bottom piece here into 2 equal pieces. I split the top into 2 equal pieces, and now I have a total of 4 pieces. And I'm going to cross out the 1/2, and I'm going to write it as my new fraction. So no longer is it 1/2. Now I have 2 shaded pieces out of 4 pieces in all. And this fraction is still 2 shaded pieces out of 4 in all. So now I can compare the fractions. 2/4 compared to 2/4. Well, they have the same numerator and the same denominator, so they must be equal. Okay, so what we're doing is we're taking the fractions that we have and looking to see, can I split the one with less pieces to make it have a common denominator? Okay, our goal is to make common denominators right now. Okay, that's essentially what we're doing, is making a common denominator. Okay, so that we can use the common denominator strategy. All right, next one, you start by writing down the fractions that you see. So in your journal, you don't have the shaded parts labeled. So I'm going to label my shaded parts. Okay, step 1. Check to see if the numerators are the same. Are the numerators the same? No. Are the denominators the same? No. But now I'm going to try and make the denominators the same by looking to see is there a relationship between 4 and 8 using multiplication? Does 4 times something give me 8? Yeah, 4 times 2 gives me 8. So I'm going to split the 4 pieces into 2 pieces. So this piece gets split into 2. This piece gets split into 2. This piece gets split into 2. And this piece gets split into 2. Please split your pieces in your journal. Okay, so now that we redrew our fractions, we're going to cross out the 1/4 because it's no longer 1/4. It now is 2 shaded pieces out of 8. This one is still 3 shaded pieces out of 8. And now I have common denominator. Let me push this up. So this is 1/8 plus 1/8. This is 1/8, 1/8, 1/8. So they're all the same size pieces. Would I rather have 2 of them or 3 of them? Well, I'd say that 3 of them is more because 2, this has an extra 1/8 in it. Okay, so we looked for common numerators, wasn't there. We looked for common denominators, weren't there. So we're going to make the denominators the same by making the pictures have the same amount of pieces. Okay, and then we're going to rewrite the fractions and use common denominator to help us solve. Okay, example 3 that's in your book, I believe, is this one, back to circles. So we have, first step, write down what fraction is shaded. 3/6 and 2/3. Okay, we're going to check to see, do they have common numerators? No. Are the denominators the same? No. But is there a relationship between 6 and 3? Yeah, well, if I do 3 times 2, that gives me 6. So I can take my thirds and make 6 pieces. If I split each of the pieces into 2 equal pieces, then I'll have 6. So I'm going to take my thirds and I'm going to split each piece into 2 pieces. So I split that piece into 2 pieces. I'm going to split this piece into 2 pieces. And I'm going to split the last piece into 2 pieces. So I took each of the thirds and split it in 2. So now I'm going to rewrite my fraction. I don't have 2/3 anymore. I have 1, 2, 3, 4 out of 6. And this one was 3/6. Now numerators aren't the same, but the denominators are. So I can use common denominator to compare. So this is like having 1/6, 1/6, and 1/6, or 1/6, 4 1/6. So would we rather have 3/6 or 4/6? Well, these 3 and these 3 are the same, and this has an extra piece. So if I want bigger, I'm going to go with the 4 pieces that are size 1/6 rather than the 3 pieces that are size 1/6. So 3/6 is less than 2/3. Okay, so our numerators weren't the same, our denominators weren't the same, but we were able to make our denominators the same, okay, by splitting the model into equal amounts of pieces. Okay, this is going to be our last easy-ish example, and then I have a hard one. Okay, so first we start by labeling the fractions that we see in front of us. So 7/12 and 4/6. Okay, numerators, not the same. Denominators, not the same. Is there a relationship between 12 and 6? And I should be thinking to myself, is there a relationship there? Well, yeah. 6 times 2 is 12. Okay, so I'm going to take my model and I'm going to split each sixth into 2 equal pieces. So I'm going to split this sixth into 2 equal pieces, this sixth into 2 equal pieces, this sixth into 2 equal pieces, that sixth into 2 equal pieces, that sixth into 2 equal pieces, and my final sixth into 2 equal pieces. And you should be doing this in your journal as we go, remember. Okay, so whatever you're doing, I'm doing in the movie, you're doing on your paper. Okay, so it's not 4/6 anymore. I now have 12 pieces. So I'm comparing 7/12, and I have 1, 2, 3, 4, 5, 6, 7, 8 shaded, and I have a total of 12 pieces. So I'm comparing 7/12 and 8/12. So now I can use common denominator. So would I rather have 7 1/12 pieces or 8 1/12 pieces? So 7 1/12 or 8 1/12. Okay, oops, I can't see that. Okay, so 7 1/12 pieces or 8 1/12 pieces? Well, 8 is more than 7, so 7/12 is less than 4/6. Okay, numerators weren't the same, denominators were not the same, but there was a relationship between the denominators where I could split the bigger pieces and make them smaller and make common denominators. Okay, this example is a little bit harder, so stick with me. Okay, first, label your fractions. 7/12, 2/4. Oops, not 2/14. 2/4. Okay. Numerators, not the same. Denominators, not the same. Is there a relationship between the denominators? So between 12 and 4. Well, I can't do 12 times something equals 4, but can I do 4 times something equals 12? 4 times what equals 12? 4 times 3. So how many pieces am I going to split each of my fourths into? 3, because I was multiplying by 3. So I'm going to split this into 3 equal pieces, this fourth into 3 equal pieces, this fourth into 3 equal pieces, and this fourth into 3 equal pieces. So now I'm going to rewrite my fractions. Our 7/12, we didn't do anything to that picture, so that stays the same. And then here I have 6 that are shaded yellow out of a total of 12 pieces. So now I have a common denominator, and I can compare using common denominator strategy. So if I have 7 1/12 pieces or 6 1/12 pieces, okay, we'd rather have the 7 1/12 pieces because that is more. Okay, so whatever the number that you're multiplying by, okay, to get to the other denominator is the number of pieces that you're going to split each piece into. Okay, so check common numerator, check common denominator. If those are no, look to see is there a relationship between the denominators. Whatever the multiplicative relationship is, split those into that number of pieces and then use common denominator to compare. So 7/12 is greater than 2/4. Okay, there are a couple examples here you probably won't get to, but when you come to the table, we're going to continue working on this, so make sure to bring this with you when you come.